All right, Dexter has 56 tiles left over from tiling his bathroom. He'd like to use them to tile the entrance of his house. Each tile has an area of 36 inches squared. So the function a of t equals 36 times t, or 36t, represents the area in square inches that t tiles cover. What domain and range are reasonable? What is the graph of the function? Okay. So what are the domain and range that are reasonable? Whoops. Well, the domain, and I'm going to call t the numbers that we're putting in, right? So the domain is that t, the number of tiles that we're talking about, is somewhere between 0 and how many did they say there are? 56 of them. Okay, that's the most that we have, the least and most that we can use. We can use as little as 0 if he decides to not do anything, and up to 56 tiles, including 56, right? So what is the range then? The range then becomes, okay, well, what if I calculated the area of 0 tiles? We're putting it in as, I could say, A of t, the output, is somewhere between, well, if you use 0 tiles, we'd have 0 as an area, and 56, well, remember, we're multiplying by 36, so if I said A of t equals 36t, that's what they told us the function is, then A of 56, the most that he could possibly use would be 36 times 56. And what is that? 36 times 56, just going to multiply it out. $2,016. So that area would be anywhere from 0 to 2016. Okay, and I did that by calculating the maximum number of tiles he could use, 56, where the rule says to multiply the number of tiles by 36, which is its area in square inches. Okay, so that's then the range out. And what is the graph of the function? Well, every time you use one tile, you go up to 36. So if you used 10 tiles, so by the way, 0 is 0, right? 0 tiles, 0 area. 10 tiles would give you an area of 360. That's about here, something like that. Okay. 20 tiles would be 720. That would be about here. 30 tiles would be 30 times 36, or 1,080. 30 tiles would be about here. And you can see this is a linear function, right? All the way up to 56 tiles, which is right around here, okay, leading you to just over 2,000 for an area. So 56 leads up to a little over 2,000. That's like right there. And it fits because look at it, lands right on the line. Now, what makes sense? Well, it certainly doesn't make sense to go beyond that because we don't have tiles beyond that. So we can say, okay, we're going to go from 0 and we're going to go up to there. Oops, but can't go past it. And that's what the reasonable graph would look like for this function. Yep, there you go. So again, domain is the numbers you could possibly put in, and in this case, it's the number of tiles. It's limited from 0 tiles is the least he could use up to the total number of tiles he could use is 56. So the domain for calculating the area would be, we have to use from 0 to 56 only. Okay, and what does that spit out? Well, putting in 0 gives you the low end. Putting in 56 into the function here gives you the high end of this. And so we can graph those as 0, 0 and 56, 2016 as the endpoints there and there, and connect.